This content is brought to you by Scouts, the strongest Salesforce hub in the Nordics and Poland, bringing tech solutions to Danish banks.
Please give a warm welcome to Marcin Rosłoński.
Thank you very much, Dorota, for the warm welcome. Hi, everyone. Nice to be here. Today, I will talk about the polymorphism in Lightning Web Components. I assume everybody knows what Lightning Web Components are. I will delve into some intricate design patterns which might be relevant for you in case you have to develop an application which is not achievable through point-and-click or declarative ways of building applications. In case you need to build your own custom Lightning Web Components, the topics might be useful, right? I will do some preaching about good quality and generic design. So yeah, this is relevant for developers, architects, but also I think to managers who should be aware if their project is growing some technical depth or if it's actually following some good design principles. Okay, so what's the agenda? Just talk briefly about what is polymorphism, right? It can mean a lot of things. I will explain the etymology of the word. We'll do some academic type fun example using a melody and how you can implement melodies in a generic way. And then we'll look at my real life project challenge from my recent project, where we needed to implement a generic component, and the slots, which are the key element of the solution, came really handy. Okay? I will first share the challenge, the dilemma, then we'll delve into the limits of or limitations or predicaments of LWC, specifically when it comes to inheritance. So inheritance was not a solution, unfortunately. Then we found that we could use slots and composition. That was quite useful. And then I will explain how that real-life project challenge was solved. Okay? And then I will have a summary, the key takeaways. Okay? So first, what is polymorphism? Well, it's a Greek, or comes from the Greek word poly, which is many, multi. Morph is shape or form, right? If you look at the dictionary, it gives the definition for biology and genetics, things that can take multiple forms, right? But we use this also in IT. When we write generic code, we do it in a generic fashion, in some abstract fashion, so that we can apply different instances of different flavors of that particular component in different contexts, right? That's why we have classes, so that we can instantiate them in different contexts. Maybe we want to create a subclass to even further customize it and use it in the same context, yeah, or in different contexts. That's one of the ways to think about polymorphism. Of course, there are other ways you could think about it as a way to even use the same variable to hold different types of components, right? For example, some people would consider that in JavaScript, which is not a typed language, it is a polymorphic behavior that one variable can hold different objects of a different type. So it's a fluid discussion. I'm kind of stealing that word to make it more attractive, this presentation, right? And let's have a look at the example which I wanted to share. So just imagine there's a melody, right? How would you write a simple program that implements this little melody, right? One way to approach this could be that you represent each note with its tone, right? Pitch, I should say, and the length, right? So I have a series, let's say I have a string which represents the melody G4 for half a note, E4 half a note. It's a very, very simple melody. This can be encoded like this, right? So how could I write a code that actually plays this melody based on such string input, right? I could, of course, do it in a blunt way, right? So that I would interpret every element of this string individually and play a specific sound, right? But then the sound that this program makes with every note could be either hard-coded or abstracted, right? So, and it's a consideration, right? If I have now a new instrument, do I have to re-implement my melody algorithm for that new instrument, or is melody something abstract, something different from the sound of the instrument, right? I could separate the two, right? One thing is the melody, another thing is the instrument that plays that melody, right? So let's have a look what, I guess, not a bad solution might look like. Here you can see, let's look at the bottom first, right? The usage, right? I'm instantiating a new instrument called guitar, and I have the string that represents the melody. And finally, I use the method which is defined upstairs here, and I pass the guitar instrument as parameter, and I tell it to play the melody, right? So you can see that the play melody here doesn't assume any specific instrument. It just knows that at specific moment, it should play a note on that instrument at a specific pitch for a specific length, right? So I have separated the two concerns. I'm sure you've heard the separation of concerns, good design pattern, right? And so the melody is here, and the instrument is separate, right? And why is it good? What's the benefit? Well, tomorrow, if I need to add a new instrument, it's quick, right? I just implement maybe a piano with all the different pitches, and I plug the piano in, and the same melody can be played on the piano, right? So which good design patterns did we use? Well, we used the separation of concerns, so we separated the two elements, the melody and the notes, the instrument, and we have no repetition of code, right? So if I did it in a blunt way, I would have the same melody, play melody on a piano, one method, play melody on a guitar, another method, and a lot of code would be repeated, right? So this is just to kind of get you warmed up to the real life problem that we faced on the project. So this is the challenge that we had. Our client needed to have a custom solution where they would be able to see various data on one page, or actually on multiple pages, but also on one page. And they were grid type data, right? So it was tabular format, different columns, not always the same object. For some of the kind of components, where you can see here the three kind of components here, for some of them there would be the download XLS button available. For some also escalate button, create task. There were different, for some a flag should be shown based on certain conditions, for others not. Here you can see that in the second one we don't have the two buttons, escalate and create task. We don't have the right upper corner component to select your unit of measure, nor the current versus predicted, right? So they were quite similar, these components, but not identical, right? So immediately we started wondering, how do we do this? How do we implement this such that we don't repeat ourselves, right? Because the obvious solution was the brute force, right? You just implement one, you copy paste, and you remove what you don't need, save it as a separate class, you copy paste again, add, remove what you don't need, and you have basically three separate classes which look similar, right? That would be very bad, especially that we needed actually 6 such grid type components, right? And of course it would, I don't need to go into, I don't need to explain in this forum why this would be bad, right? Obviously, maintenance is an issue, right? If I need to change anything, or maybe add some additional link for every component. I cannot do it in one place. Maybe I need to change styling. I cannot do it in one place. I have to repeat my work in 6 different instances, right? So that was the dilemma. How do we do this? We first thought of inheritance, right? In the Java world, you can use inheritance to kind of extend your components. You can customize. You can maybe reduce some behavior, mute certain elements, right? So we thought, why not? Let's see. But there is a problem, and I'm going to switch to the next slide. And I'll have 3 slides about the inheritance predicament in LWC. Well, the main problem is that you can inherit from an existing LWC component. Actually, that's what we do every day when we create a new LWC component. We inherit from Lightning element, right? However, once you have defined an HTML layout of that component, you can no longer inherit from it. I mean, you can, but only the JavaScript part. So if you have component, let's say I created a new component, my LWC, it has a certain layout. Let's say it has a button, right? When I create a subclass of my component, my LWC component, that subclass will not inherit the layout. Right? It will only inherit JavaScript, and you have to define your layout from the beginning, essentially, right? So inheritance is good; you can still use it. I'm not complaining completely about it in LWC or JavaScript, but it's not useful in this context, right? So this was the key issue. I'll switch to the next slide. So what are the implications? Well, the developers will find themselves duplicating HTML, right? That this is the challenge of copy-paste. It deviates from the principle of object-oriented design. Redundant code is the risk, right? It's basically 3 points are saying roughly the same thing. That's the challenge, yeah? What are the workarounds? Let me move over. Workarounds and best practices. So the general recommendation, if you Google about inheritance or if you go on ChatGPT, is that you should use composition rather than inheritance. That should be your go-to approach, the preferred approach when you design your components. You should try to compose, wrap around something that exists rather than inherit from it. Inheritance is quite problematic and kind of get out of control quite quickly. It's usually, if something can be used, if we can use composition, that should be the preferred approach generally. One other suggestion for sharing a template, which is the HTML part, is to use the slots, right? The last bullet here mentions the slots. Slots allow you to make flexible composition, right? And that's what I will talk about today. That's my main topic for today, right? The slots. How we can use slots to implement flexible composition, okay? So let's talk about the slots. What is a slot? Understanding slots. So slot is a normal HTML element tag that you can use inside your layout definition in the template. You can give it a name. Actually, names are optional. If you want to know more about it, I'm sure you can find that in the documentation. But in the examples that I will be showing today, I will only be using named slots. So here I have 2 slots. One is called header, the other is called the body. And you can see that they have the default value each, right? There's a default header and a default body text, right? However, this is definition. And However, when I instantiate this component, the specific my slot component, I can inject whatever I want into that slot. Right? So let's look at two examples of instances. Not class definition, but instances of where I'm using this component, okay? So there's sample instance 1 and sample instance 2. You can see that in the sample instance 1, I am injecting under header slot an H1 element. So suddenly, whatever was the header here will become H1. So I control from the instance what is that element. So I can actually override certain styles as well, right? And I have overridden the content, right? So this is the header. Rather than the default header, it will say this is the header, right? For the body, I did something similar, except this is a paragraph and it says this is the body content, which overrides the default body value, right? The second instance is only interesting because you can see that it's skipping the definition of the header. So the header will remain the default header, right? This is where the default value will kick in. Okay? Quite simple. Yeah, but we'll see how powerful it is very soon, okay? Okay, one more example. Sorry, there's one more example I wanted to show you to kind of get you into the direction how this can be useful, right? Imagine that I need to build a component, one tile like this, where I'm fetching progress from the backend, let's say, or from some service, wherever. And once that button is pressed, the progress is fetched, and I would like to display that on some sort of donut chart or some sort of progress bar, right? However, I don't want to necessarily assume in the style what kind of presentation the progress viewer should have. I just want to offer a place in my component where the progress will be displayed. I would like to assume what method it will have to accept my progress update, let's say set progress with a percentage. But the actual implementation, whether it's this kind of picture or this kind of picture or maybe a flat horizontal bar, that should be a decision maybe of another developer, or maybe it will be different in two different contexts, right? I would like to isolate these two elements, these two aspects. Just like we isolated the melody from the notes, from the instrument, maybe I would like to isolate the logic for fetching data and evaluating the progress from the actual presentation of the progress, right? So how could we do this? This is a slightly more advanced version of the slot usage. Here's the tile that we can see here, okay? You can see that it has one slot which is called progress view, okay? I will talk about the on-slot change in a moment. What it surely also has is the button which fetches the progress, right? We won't go into the detail of how this process is fetched. There are many ways to get it from the Apex, right? But the key thing is, if you look at the JavaScript implementation, is that this component here, let's say progress view, progress controller, doesn't really assume anything about the progress donut or progress presentation, except that this component has the method called set progress with one parameter that actually is the progress, right? So this gives us the flexibility to inject into my instance different implementations of this progress viewer, right? So it's kind of, you should think about it maybe, or the way I think about it is that even though we are talking about LWC, within that front-end layer, right, there can be components which are more front-end and more back-end, right? So even within the whole, because we usually call front end, the whole JavaScript, HTML, right? And back end is Apex. Well, actually, within the front end itself, within LWC itself, this component is more back end, whereas this little thing here is even more to the front of that front end, yeah? So you can still organize your code in layers in this way and kind of separate it to perhaps give the donut thing to one developer and the actual logic to another developer, right? So it also helps you organize your work, right? Okay, so let's look at how we solved it for the project challenge. So this is now about the solution. So back to our complex grids. You can see here that we had, so what you're seeing here is actually definition of an instance, right? I'm not going to bore you with the actual definition of the whole component as a class. This is an actual instance, a specific instance for this specific instance, right? So you can see that I'm populating slot KPI status flag, which is this little flag here, with a component, KPI status flag. That's the class I want to use. I'm also populating the CSV generator. That's the only button I have here, right? I'm using CSV generator class for it. I'm giving it some attributes, so you can see that actually, and this is an interesting point, right? Because usually when we define LWC components in a more traditional way, we encapsulate them and they are closed, right? But here I can actually tell this KPI grid parent that it will have inside the slot called CSV generator, that it will have this specific instance CSV generator, and here are the attributes of that generator. So I can actually specify the attributes of a subcomponent, right? Which is great flexibility, right? If you think about it, right? We have some other slots as well, like the selector slot, which is the right upper corner there. There's the record grid, right? It's the same component you will see on the next slide, the record grid, but I'm selecting which are the supported fields that it will show, right? And I would like you to pay attention also to the bottom slot, which is special because it's a plugin, right? We are leveraging the slots to implement a plugin pattern, right? Because I would like to be able to influence the parent component, the KPI grid parent, in terms of when it should be visible, how it should retrieve its records, and so on, right? So I can use the concept of plugins. I will talk more about this in a moment. Okay, let's look at another instance of this KPI grid parent. This was for AV risks, so-called. Here's an instance for top cuts, okay? Here I don't have completely the slot on the right upper corner, right? You can see that it's blank because I didn't populate it. I still have the CSV generator, excellent. I have record grid, which is this part, but I'm giving it different attributes, so I have that flexibility. And I'm using a different plugin, right? Even though the slot is the same, KPI grid parent plugin, the class that I'm using is different. Here it says KPI grid parent plugin top cuts. So I have a specific plugin that I'm injecting into my KPI grid parent under the KPI grid parent plugin. Okay, this one is for top cuts, right? You can see here, right? Top cuts. If I go back to the previous slide, there was a plugin specific for AV risks. Okay. Okay. So let's look at the third slide about the solution. This is about the plugin pattern. We'll dive into this a little bit. So I mentioned on the bottom we have the plugin definition, and now what the code may look like if you would like to use a plugin. How can I implement different customization hooks, right? So this is just a very basic JavaScript. I have reduced 95% of this KPI grid component JavaScript just to illustrate to you this principle. It's just to illustrate how we use the plugins. Yeah. So imagine that there's a isVisible property on this KPI grid parent, which controls if the component should even be visible or not, right? And by default, it should be visible, right? But in certain circumstances, which I want the plugin to decide about, I would like the component not to be visible, okay? So I have this method here that gets me the plugin, if it exists. It may be null if I didn't inject anything into that slot, right? So I'm querying the shadow DOM for query selector using the data ID KPI grid parent plugin, right? And then finally, at some point in the logic of the KPI parent, it will decide to set its visibility, right? Every time maybe it pulls the data, it will want to consider, should I be visible or not, right? And it will execute this method by setting the property is visible, and will decide in the following way. If I don't have a plugin, right, if I assume I'm visible, but if I do have a plugin, I'm gonna ask my plugin to tell me if I'm visible, and I will pass myself as a parameter so it can interrogate what is my state, right? So perhaps AV risk will tell the KPI grid parent to completely disappear in case there are no records, right, to be shown. Or perhaps it will be still visible, but with just empty list, right? So the behavior can vary, right? Right, so you can imagine yourself that you can implement various other customization hooks that will be useful, and there's not anymore such a great need for inheritance if you can use the slots together with the plugin pattern. Yeah? So let's summarize. Configuration. Slots enable dynamic configuration. You could see in the previous slides that I am able to specify attributes of my subcomponents explicitly, right? I don't have to expose another attribute on the parent component to control the subcomponent's attribute. I can just instantiate and control the attributes of the subcomponent, right, directly. I can decide what class I should use for implementation of a specific slot, right? So I can be flexible in terms of which class I would like to use. It doesn't have to be one specific implementation. By using slots, I'm opening my component to different injections and different implementations of a specific method contract. Let's say I have a few methods that a component must implement, that such a subcomponent must implement. That's all that I'm assuming, right? And everything else is in the hands of the specific subcomponent. And finally, the plugin pattern, right? Which is basically kind of leveraging the two upper benefits, but it's something so powerful. I wanted to highlight that indeed it is something worth noting at the top level. So that's what I had prepared for today. Any questions? Or what are your questions, I should say?
Hey, well-deserved applause. And if we have any questions, I'm ready with the microphone. Okay, there you go.
Yeah, thanks for the presentation. I'm interested in the plugin pattern. What was the reasoning initially behind it? Like, what can you do with a plugin pattern that you can't do with just configuring the main component? Because I understand that it knows about the main component, a component knows about it, so that there's no like inherent separation. So maybe you can give an example why it's necessary.
Sure. So what I wanted to avoid in this particular case is that inside our KPI grid parent, we would have the anti-pattern of the switch statement, right? You should usually not have in your code a bunch of if statements, right? Where it says, if I am AV risk, I should do such and such. Else, if I am top cuts instance, I should do such and such, right? The kind of the generic, the highest level of implementation of this generic KPI grid parent, in this case, should not really know what is the particular behavior of any specific instance. That should be injected ideally dynamically so that this generic part is very clear and short, and we can then and by having plugins, I'm also opening the door for further extensions, right? I'm not limiting my implementation just to maybe these 5 or 6 cases that I have thought of when I was writing KPI grid parent. I'm opening it to the 7th or 8th later when that comes along.
Okay, do we have any other questions? I'm looking, but I can't see anyone waving, so I think this concludes our Q&A session. Thank you so much for your question.
Thank you very much.
And also thank you so much for your presentation. I think the Accenture team is also ready to join us on the stage to get the award. Okay, so right now Paweł is presenting the Accenture team with the SForce award, and now we have a time for our photographers to take some pictures.